Okay, so hello and welcome again for our lesson for today. So we're going to discuss the previous sheet work we had on time rates. So for number 6, a ladder 5-meter long leans against a vertical wall of a house. If the bottom of a ladder is pulled horizontally away from the house at 4 meters per second, how fast is the top of the ladder sliding down when the bottom is 3 meters from the wall? So here we need to have an illustration. So let us have here as the wall, and then the ladder. Of course, we have a floor in it. Then this ladder is leaning on this wall, and it is 5 meters long, and then it is being pulled away from the wall, so that this horizontal distance will be now a variable x. Same true with y, which is going down as we pull it on the foot of the ladder. Say this is a variable y. So the rate at x, according to the problem, okay, so dx over dt, or the speed of that change in x, is 4 meters per seconds. So when x is 3 meters, what is our rate of y, or the change in y with respect to the time? Of course, we can relate to Pythagorean theorem, applying or relating x, y, and 5. By the way, ang technique natin dito is we look at all of those given and how to relate them through an equation. So in this case, we have all of the dimensions. We do not have any angle, so we will stick with the Pythagorean theorem for that. So we can say now that this 5 squared is equal to x squared plus y squared. So we need to obtain some values here, substituting the conditions in the problem, wherein when x is 3 meters, we will be having a value for y. So there will be a corresponding y value, which is 4 meters. So we'll be needing that 4 meters if we're going to derive the original equation. So the left hand side will become 0 because that is a constant. And then the first term is 2x dx over dt. And then the second term is 2y dy over dt. So we now substitute what we have obtained and what are the givens. See, x is 3 here. Okay, so this is 3, and for y, that is equal to 4. And dx over dt, or the rate, is actually given in the problem. So all of the given and the obtained values are substituted. Then we can now compute for the unknown rate of y, which is negative 3 meters per second. So negative just simply indicates that our speed is towards downward direction. Okay, so that is a downward motion. Okay, moving on to the second problem, we have number 7. We have here a lighthouse which is positioned 2 kilometers from the shoreline. So this lighthouse is actually tracking a car which is traveling at a constant speed along the shore. So if the searchlight is rotating at the rate of 0.25 revolutions per hour, determine the speed of the car when it is 1 kilometers away from the point on the shore nearest to the lighthouse. So here we have a road. Of course, there will be a shoreline in it, and on the shoreline we have the lighthouse observing what is passing on that road. So we have a car, or the nearest distance from that shoreline up to the lighthouse is actually 2 kilometers. Okay, so this is point on the shore nearest to the shoreline. Take note of that. And as this car moves away from the point, therefore there will be a variable x, okay, with respect to time, no? so that we can form here a right triangle. So as I have said, we are going to form a relationship between the given. So in this case, meron na tayong hypotenuse pero walang given yan. So it has no bearing to this right triangle. Ang may bearing lang is yung may given. Say we have x and 2 kilometers. I think we still need a variable here so that we can complete a certain equation. Say we have here an angle, y angle, because on the given we have a rate of rotation. So when we say a rate of rotation, that refers to the angle. So the rate is actually 0.25 revolutions per hour. So remember that if this line of sight changes from one point to another, observing this car along the road, okay, nagro-rotate yung angle niya. Okay, so angle theta changes with respect to time because it is following this car moving from one point to another. Okay, then by that we can say that d theta or all over dt, or the rate of rotation with respect to time, is 0.25 revolutions per hour of that car, which is located initially on the point of the shore nearest to the shoreline. So remember to convert it first before we are going to inject or integrate that into our equations, because remember that when we deal on angles, we need to convert it in terms of radians, okay, not by revolutions or not by degrees, especially we are referring to the rate. Okay, so we convert that to radians. Okay, so take note of that. So we need to have a conversion factor here from 0.25 revolution per hour. Ito yung given. So ano yung conversion factor niya? So the conversion factor is actually 1 revolutions is equal to 2 pi radians. So itapat mo lang yung revolutions doon sa opposite ng revolutions, and then pair it with its equivalent conversion factor, which is 2 pi. Okay, so that we can now cancel that revolutions, so we will come up with radians per hour. So this is radians, okay, radians per hour. So we do not need to convert hour anymore because the given here is in terms of hour. So our result later on will be in terms of hour. So again, paano natin marirelate yung mga given? So mga given is the two legs, not the hypotenuse, okay? But rather it is the angle, so that we will utilize this theta and then this 2. So it's more appropriate to express in terms of tangent. Theta is equal to x, opposite to theta is x, adjacent to theta is 2. Okay, so that's the relationship we need. And then of course we will just have to differentiate that with respect to time. So the differential of tangent is actually secant squared theta d theta all over dt, and that is equal to 1/2. Okay, i-isolate mo lang yung constant ng x over 2 is 1/2, and then derive x with respect to time, that is dx over dt. Okay, so this will be the acquired equation. Of course, we need the value of theta here, so we can obtain that by having x is equal to 1. That is actually a condition in the problem when it is 1 kilometers away from the point on the shore nearest to the lighthouse. Okay, when x is equal to 1, we just have to substitute it on the original or the formed equation. Tangent theta is equal to x over 2. So we'll come up with tangent theta is equal to 1/2. Getting the arctangent of that one, we have 26.57 degrees. So yun, substitute lang natin yung equation, and with the converted d theta over dt here, okay, so equate it to the right hand equation. So obviously we will be having the unknown, which is dx over dt ops. We need to express our secant in terms of its identity sa cosine, no? Because we cannot find for calculation purposes, we cannot find secant function in your calculator, so take note of that. That is why we converted this, and then secant here is squared, so all of the inner term or the equivalent of secant is 1 over cosine 26.57, all of which are squared because secant here is squared. And then 0.5 pi, just copy the remaining functions. We'll come up with the speed along x. So the change in x with respect to time, or the speed of the car moving, is actually 3.93 kilometers per hour. Okay, so that's it for the 7th problem. Okay, so moving on. The two adjacent sides of a triangle are 6 meter and 8 meter respectively. If the included angles changing at the rate of 3 radians per minute, at what rate is the area of the triangle changing if the included angle is 30 degrees? So remember that we are getting here the change in area with respect to time when the included angle is 30 degrees, and then the rate of the angle is changing at 3 radians per minute. So here we do not know yet the exact shape of this triangle, but rather we will be focusing on the given dimension. Of course, there will be an included angle. So if your problem had mentioned about the included angle here, which is actually changing at the rate of 3 radians per minute. Okay, so therefore d theta over dt is 3 radians per minute. So we can relate the given, okay? Relating the area with the given. So adjacent, dalawang adjacent sides at may included angle, parang gunting yan, no? So ito yung tinatawag na scissor formula for the area of a triangle. So adjacent side with its included angle, say AB, and theta is the included angle between AB, we can say that the area of the triangle is 1/2 AB times sine of theta. So this is in your trigonometry, no? Again, we will obtain some given here, substituting 30 degrees later on, and get the rate of area with respect to time. So all we need is to execute differentiation on the whole equation, on the formulated equation with respect to time. Okay, of course we're going to substitute a and b here because a and b is a constant value that needs to be substituted, okay, with respect to time. So the left hand side will become differential area with respect to time is equal to, of course, just multiply 6 times 8 as a product, we have 48, and then the differential of sine theta is actually cosine theta, and the chain rule is we differentiate theta with respect to time is d theta all over dt. So by that, we'll just have to substitute here the 30-degree angle as a condition in the problem, and finally come up with the change in area with respect to time, which is 62.35 square meter per minute. Okay, so that's it for number 8. Okay, so for number 9, we have at 12 noon, boat A left the pier in the direction north, 10 degrees east at 36 nautical miles per hour. So we have another time here at 1 p.m. Another boat, say boat B, left the same pier in the direction north, 70 degrees east at 28 nautical miles per hour. So the question is, how fast were they separating at 2 p.m.? So in this case, we have various time in the problem. So kung naka-encounter kayo ng ganitong problem, all you have to do is to assume that your time is the total time elapsed, okay, at the latest time. So what is the latest time here? It is 2 p.m. Okay, so remember that. Yung T dito, nagsimula ka sa 12 noon, so therefore, ang T dito is equal to 2 hours from 12 noon. So that's the condition, meaning yung variable T mo dito ay yung time after the latest time, which is 2 p.m. Of course, we need to place that into a Cartesian with a direction because the given is in terms of the directions, ano? So first we have at 12 noon, say this is boat A with the given direction, okay? So according to the problem, we have north. Where's the north? This is the north. It is measured 10 degrees east, okay? So we form a line here and have the angle 10 degrees. So the speed of the boat is 36 nautical miles per hour. Remember that the distance is velocity times time. So therefore, I will simply multiply velocity times time here. Okay? So boat A here will be having a time equivalent to T because unang-una siya yung nauna. Okay, so our reference in time is actually from the earliest time up to the latest time. So anong earliest time? 12 noon up to the latest time, that is 2 p.m. That is why it is multiplied by a bare T, or walang bawas, walang kulang, buo yan na T. So from 12 noon up to 2 p.m. buo yan na T. Unlike sa boat B, kasi alauna na siya pumalaot, so at 2 p.m. meron na dati yan, ano? Okay, meron na dati yan, boat A, and then here's another boat. It is measured from north, ano? Measured siya sa north, pa-east, ano? 70 degrees. Okay? So, ito, 28 yung speed niya. 28 times T minus 1. Bakit T minus 1? Because, alauna na to. Okay? So, let us correct this one, ano? Dapat ito at 1 p.m. Sorry. So, this should be at 1 p.m. So, ilan yung dapat may bawas sa total time na T kung alauna siya nag-start mag-travel. So, meaning, we're going to deduct 1 hour from the original T. Okay? So, again, this is supposedly 1 p.m. This is supposedly 1 p.m. So anyway, our concern here is at 2 p.m. Just stick to this one, and then just bear in mind that we just deduct 1 hour. Nag-deduct tayo ng 1 hour. Bakit? Kasi nga, nahuli siya. So, by 1 hour. Okay? So, we deduct 1 because t here is time measured from the earliest up to the latest. So, now, mababawasan yon kasi alauna siya. Nahuli siya ng 1 oras. Okay? So, 28 times t minus 1. Okay. So, if they continue to travel with that certain direction, kasi nga, variable yung t dito, i-project mo lang to, okay? Yung point between the two, or just make a line between the points of both A and B, and then get the rate of that. Say that is S. Our unknown here is the change in S with respect to time. Kasi lumalawak at lumalawak yung S as time passes by. Okay? So let us have a larger figure here. Okay, so of course 60 degrees yan kasi 70 minus 10 is 60 degrees. So we need to establish the inner angle of that triangle, So ngayon, again, let me reiterate that we need to relate here the given, So unang-una, this is the opposite of the given angle with a given adjacent side. So adjacent side included angle and the opposite side. So we can utilize here cosine law. Okay. So S squared is equal to 36. Okay. This side, that is squared, and this side, all of that is squared, and then less 2, okay, times this two sides here. Okay, so the two sides is 36t times 28 times t minus 1 times cosine of 60 degrees. Okay, so that is all about cosine law. And then of course, as usual, we are going to utilize the conditions in the problem. So from 12 o'clock, the time elapsed up to 2 p.m. is actually 2 hours. So that 2 hours will be substituted on the different or the original equation, So we'll come up with S is equal to 62.86 nautical miles. So we will be needing that if we're going to derive the original equation with respect to time. So of course, before we were going to do that, it is desirable here to simplify first your equation. So ito, by distributive property, will come up with 1296 t squared, and then again 28 squared by distributive property is 784, and this one will be expanded to t squared minus 2t plus 1, and then all of this equation of course will be distributed to this expression t minus 1. So kapag minultiply mo, negative 2 times 36 times 28 cosine of 60, that will yield to 1008. So negative 1008 distribute mo dito times t siya. Okay, so negative 1008 times 1008t times t, that is equal to negative 1008 t squared, and then negative times negative will yield to positive 1008t. So that will be the simplified equation, and then execute differentiation with respect to time. So 2s ds over dt for the left hand side, and then for the right hand side, baba yung 2 dito, 1296 times 2, that is 2592 times t, dt over dt is just 1, and then plus 784. Differentiate the inner term here Okay? Inner term, 2t. Okay? First term, 2t. Minus 2. 0 na yung 1. Okay? Then minus 1008. Baba yung 2 dito times 2. Mabawasan ng isang exponent. So that will become t. And then plus 1008. So tanggal nyo yung t because that is differentiate to dt over dt. So by that, we'll just have to substitute all of the acquired values and the conditions. Say we have 2 R's and having an S of 62.86. So substitute mo lang yan sa buong equation, then manipulate, determine ds over dt. We have 29.65 nautical miles per hour. Okay, so that's it for that problem. Okay, for number 10, we have here a Ferris wheel having a radius of 10 meters. No? Its center is 12 meters above the ground, and a passenger is 17 meters above the ground. He is moving vertically at the rate of 1.81 meter per seconds. Okay, so just to have a brief definition or description of the problem, no? Itong kapag passenger ka, you are actually moving at a certain rate of y, no? So wala siyang pakialam sa movement mo sa x. Actually, that is just rotating. Pati yung y, that is just rotating. So our concern is actually y, because here the condition, the problem, we need to determine y, because when the passenger is 17 meters, that is a y distance, and the rate of the vertical is given, that is actually y, or 1.81 meter per second. So that is along the vertical. So our concern here are vertical dimensions, no? Okay, so here's the Ferris wheel, and the center of that Ferris wheel is 12 meters above the ground. So bakit kailangan natin yan? Ito, if this is the Ferris wheel, ano, at some point tumaas siya from 12 naging 17 meters. So kapag ka-level niya lang kasi to, that is 12 meters, and at some point 17 meters. So when y is 17 meters, what is the speed of rotation of the wheel in revolutions per minute? So ito mas mataas to dito sa level ng center ng Ferris wheel because that is 17 meters. Anyway, that point is actually a variable. Okay, so if that is 12 meters, therefore that is y minus 12, no? At yung y minus 12, let us project that along the level of the center, and then also project here the radius given, that is 10 meters. So extend mo lang yung linya na yan, then we'll be having here a right triangle with a certain angle theta. So anong given dito? Theta, and an opposite dimension to theta is y minus 12, and hypotenuse is given. We relate opposite and hypotenuse, of course. Our function is sine theta. Okay, by the way, the rate of y is actually changing at 1.81 meters per seconds according to the problem. So we formulate now the relationship of those given through sine. We will have that function sine theta is equal to y minus 12 all over 10. So by cross multiplication, we will be having that, and then of course execute differential of that equation with respect to time, ano? Okay, differential of 10 sine theta is 10 cosine theta d theta all over dt, and then the right hand first term is dy over dt, constant naman yun, so 0 yung 12, ano? So when theta is equal to 30 degrees, of course we'll just have to substitute in that equation, no? dy dt rin 1.81, substitute mo yan, then kuha na yung d theta all over dt, which is actually the rate or the speed of rotation. Okay, the rate of theta with respect to time, or the speed of rotation, which is the unknown in the problem. So in here, the resulting unit is radians per second. We still need to convert that into RPM, or revolutions per minute. So we will be having here a conversion factor that 1 revolution is actually 2 pi radians. Ano? So ngayon, itapat mo lang yung radians, opposite nung nasa taas. So dapat nasa baba yung radians, lagay mo yan dyan. So yung nasa ibabaw is revolutions. And with that, radians will be cancelled. We still need to convert seconds in terms of minute. So as we all know, it's common that 1 minute is equal to 60 seconds here. So saan mo ilalagay yung seconds? Of course, sa opposite ng second, ano, para makakancel. So nasa baba yung second, dapat nasa taas yung second ng conversion factor mo. Therefore, the equivalent conversion factor will be situated on the denominator, which is 1 minute. Ano? So therefore, d theta all over dt will be equivalent to 2 revolutions per minute, or 2 RPM. Okay, so that completes the solutions on your previous sheet work. So I think it's better for you to practice. So have a good day, class, and good luck.